Distributive property. You've most likely seen this before. If you want to break some things out of the parentheses, we don't want parentheses anymore. We want to get that C out or get the B out of the parentheses. We can distribute A through the parentheses, and that is multiplication. So I'm going to use the document camera. I'm going to show you why that works, or a little bit, and we'll look at some examples. So if we want to use the distributive property, which I affectionately call the Oprah property, we're going to say, okay, this 2 here on the outside of the parentheses is being multiplied to everything inside the parentheses. So it's you get a 2, and you get a 2, and everything gets a 2. So everything inside the parentheses, no matter how many things are inside the parentheses, everything gets that 2 multiplied to it. So it'd be 2 times 7, 2 times x, 2 times 3. And we keep going. No matter how many things are inside that parentheses, everybody gets a 2. So you just distribute that out to everybody. It is multiplication. Distributive property is multiplication. So look at that when you actually distribute those out. We'd end up with 14. 2 times 7 is 14. 2 times x is just 2 times x, 2 x's. And that minus sign between the x and the 3 stays there. It just becomes 2 times 3, which is 6. You could then combine some things together, which we'll talk about in, I believe, the next lesson. So I'm going to leave it here as 14 plus 2x minus 6. The reverse of that, we'll get to again in a different section, I think section 4 maybe. But the reverse of that distributive property, we take the same amount from everybody. So I affectionately call that the taxes property. We divide 2 from everything. So instead of multiplying 2 to everything, like Oprah, we're not giving everybody 2, we're dividing, we're taking away, we're taking out, I guess, we're factoring out the same number from everything. So you can go both ways with this, and we will go both ways with this. And that reverse distributive property is going to come back in section 4. Properties of exponents. So that was actually the end of section 1. So we just finished section 1. Section 2 is all about exponents. And so I'm gonna show these properties, and you'll see some examples of these properties. But the product rule, the power rule, and the quotient rule, pause it if you need to, write these down, and then I'm going to show kind of each one, and we're going to look at a shortcut. So these properties are saying, what's the shortcut? If you have x to the a times x to the b, how can we rewrite that in a different way? Okay, so I'm going to go over to my document camera, and we're going to look at the first one first. So if you had something like x to the 3rd times x to the 5th, if I expand that out, we'd have x times x times x. Remember, x to the 3rd property here means x times x times x. X to the 5th property means x times x times x times x, 5 x's. And we've got multiplication in the middle. Well, if we look at that, we've got x times x times x times x. It's all multiplication. It's all the same letter. It's all the same number, whatever it is. But we have 8 of them now. 1, 2, 3, 4, 5, 6, 7, 8. So x times x times 8 times could be written as x to the 8th. A shortcut then, if you have 2 powers being multiplied together, where it's the same base, so the big number has to be the same, a shortcut could be that instead of writing it all out like this and expanding it, we could just add 3 plus 5 together and get x to the 8th power. This is why it works, is because when you expand it out and count how many x's there are, you get 8 of them. But the shortcut is, if you're multiplying 2 powers together, you can add those exponents together and get x to the 8th power. So that is this one right here. X to the a times x to the b is x to the a plus b. You can add those powers together. The next one, if we have a power raised to another exponent. So if we go back to, excuse me, here it is. If we go back to my document camera, we have x to the 3rd to the 5th power. And we're doing that. That says we have x to the 3rd 5 times. 1, 2, 3, 4, 5. So that fifth power there says whatever this base is, x to the third, we're doing it 5 times, multiplied together. Well, we have a rule now. We have a shortcut, I should say, that if we have the same base being multiplied together, we can add the exponents. Well, these are all the same base, so we can add all of these exponents together. 3 plus 3 plus 3 plus 3 plus 3, x to the 15th power. The shortcut then is if you have one base with 2 exponents, a power raised to another exponent, we can multiply those exponents together. 3 times 5 is 15. And here's why it works, is because when we expand it out, we can apply our previously learned shortcut and get our answer of x to the 15th. Before I go back to the main screen, I'm going to do one more, the quotient property. So if we have x to the 5th power divided by x to the 3rd power, the 3 and the 5 I'm just making up. And so it doesn't matter what numbers you have here. This would be the same as 5 x's being multiplied together in the numerator and 3 x's being multiplied together in the denominator. If I divide anything divided by itself, x divided by x is 1. X divided by x is 1. X divided by x is 1. So really we have 1 times 1 times 1 times, we have 2 x's left over. 1, 1, 1, x, x. So that's just x squared. Got 2 x's left over. Because these, I say cancel away. They're not really canceling. They're dividing to 1. But we can cross them off as 1. The shortcut then is if you have 2 powers being divided, we can subtract the exponents. 5 minus 3 is going to give us 2. So that's the shortcut that we can take for that. Going back to our properties then, the product rule says that we can add those exponents together. The power rule says we can multiply those exponents together. And the quotient rule says we can subtract. So again, pause it, write those down if you need to. I'm going to move on though so I don't run out of time. 2 other ones, and these are a little bit more unique, is the 0 exponent rule and a negative exponent rule. I'm going to start with the 0 because that's an easy one, and then I'll move on to the negative exponent rule. So the 0 product rule, or 0 exponent rule, anything to the 0 power is 1. It's not 0, it's actually 1. So I'm gonna go over to my document camera. I'm not going to prove this, at least not now, because I don't think I have enough time. However, anything to the 0 power is always 1. Doesn't matter if it's 5 to the 0, 8 to the 0, 50 billion to the 0, it's always 1. And for the negative product property, or the negative power, the negative power rule, if there's a negative exponent, we're going to go with a -2. That doesn't really make sense, because x squared would be x times x. X to the 3rd would be x times x times x. There's 3 of them. X to the -2 means you have to multiply x times itself -2 times, which just doesn't work. And so the way we deal with that is we turn it into a fraction. The exponent becomes positive, so that way we can work with it, but we flip it inside of a fraction. We do an example of that with numbers. So if we have, let's say, 5 to the 3rd power, 5 to the -3rd power, 5 to the -3rd, we'd write that as 1 over 5 to the 3rd power, which now we can actually do. 5 to the 3rd power, 5 times 5 times 5 is 125. So it'd be 1 over 125. And that would be what 5 to the -3 is. To expand on that, I've got 20 seconds here really quick. To expand on that, if you have 4 to the -3 over 2 to the -2, a negative in the denominator will flip it to the numerator. A negative in the numerator flips it to the denominator. And then 2 squared is 4. 4 to the 3rd power is going to be 64, I believe. And then we can reduce it, but that'd be it.